Hello everybody, welcome to the video. In this one I'm going to explain what integration is. Now I'm going to just be very simple about it. So what is integration? What is this? Integrals that I have to learn. Simply is just the opposite of differentiating, the opposite of making a derivative. That's the way straightforward way to put it. So for example, if I have a function and I make its derivative, I get this. In the notation for integration, if I have this sort of situation, well, the integration of f prime of x is of course going to be f of x because it's the opposite. So I can go from f of x to the derivative and back through integration to f of x. For example, if I have x squared, I make its derivative, what do I get? 2x. So if I integrate 2x, now don't worry about the notation right now, what am I going to get? X squared. Similarly, if I have the natural logarithm and make a derivative, I get 1 over x. If I do the integration of 1 over x, I get the natural logarithm. That's it. Now, all this funky notation, we're about to explain it right now. But you have to understand that truly integration, that's kind of it. Now, it's going to have applications and interpretations, but that really is it. It's just the opposite of making the derivative. So, notation. Let's explain the notation. Okay, so this is what we have. So if I have integration of x dx, it gives me x squared over 2 plus c. Right? Think about it. If I make the derivative of this thing here, I am going to get x, right? Because the 2 will go in front, cancel with the other 2, and I'll be left with the x. Wonderful. So what do the symbols mean? Well, this thing means integration. Hey, you're going to make integration here. That's all it means. This funky s, this means integration. The dx is actually the differential of x. But let's keep it simple for now. It just means you're going to integrate for variable x. And in a way, it's kind of the other side of the sandwich. It tells you where the meat ends. Like integrate everything that's between the big long S and the dx. That's what you have to integrate. No need for brackets. We have these things here to let us know. And the plus c stands for a constant value. Now, why is that? Because if I make the derivative of this thing here, what's going to happen? Well, what's going to happen with this? It's going to go away. So for example, if I make the derivative of any of these, realize that the only thing that's changing here is the value that's adding and subtracting. All of these, their derivative is x. They have the same derivative, which is why I have to add the plus c, just to signal, hey, you know what, there could be a constant value here. So that's what the notation means. But really, again, I insist, all it really is, integration is just the opposite of making the derivative. Now, what do we use it for? Let me give you a bit of an idea of what this means and how do we use it. So, what do they tell us? They're going to tell us the area between the curve and the x-axis. Whoa, that's kind of strange. Okay, let me give you an example of how this is going to work. So, here I have the straight line, 2x, right? Great. So how this is going to work? Well, if I'm going to say, what is the area between this line and the x-axis, right? Well, of course, that area is going to be infinity, right? Because it's going to get very big. So let's bound it. Let's bound it between 0 and 1. Let's say, okay, between 0 and 1, what is the area here? Well, the area between the curve and the x-axis between x equals 0 and x equals 1, here you have it. It's this triangle here. If I do base times height, height is 2, base is 1, I'm going to get that the area is 1. Great, so the area of this triangle is 1. Well, it turns out that I can do this also using integration. How? Well, I do the integral from 0 to 1 of the function 2x dx. Now, I'm going to make the integration. It's going to be x squared, and I'm going to evaluate it between 0 and 1. You will learn how to do this properly. Don't worry about it, and it will give me 1, and it will give me the area. Now, this is going to be useful for more complicated functions than this one, right? This one was very easy. We could just do base times height. But that really is going to be one of the main things we're going to be using integration for. Thank you very much for watching. See you next time. Goodbye.